Hello everyone, this is Ketish here. In this video, I'm going to go through the AQA Chemistry Paper 1 Higher Tier from 2025. Question number 3 is on the topic of chemical changes. This question is about metals and metal oxides. Tin is extracted from tin oxide using carbon. The equation for the reaction is SnO2 plus carbon gives you Sn, which is tin plus carbon dioxide. Which substance is reduced in this reaction? For it to be reduced, it has to answer in terms of oxygen. So oxygen is lost from tin oxide. So substance reduced is SnO2. You could write tin oxide. Reason, since it loses oxygen. Remember, for something to be reduced, it has to either gain electrons or lose oxygen. Why can carbon be used to extract from tin? Why can carbon be used to extract tin from tin oxide? The reason we can use carbon is because carbon is more reactive than tin. Carbon is more reactive than tin. Cadmium, Cd, can be extracted by the reaction of cadmium oxide with carbon. The equation for the reaction is CdO plus carbon gives you cadmium plus carbon monoxide. Calculate the percentage atom economy for the production of cadmium in this reaction. Now, how do we work this out? First of all, we need to work out the percentage atom economy for the production. So let's work out the total relative formula mass of cadmium oxide and carbon. So cadmium oxide plus carbon, total MR, formula mass or molecular mass, not formula mass, molecular mass is 128 plus 12, which is of the reactants. That gives me 140 grams. Now, cadmium on its own is 112. So this carbon monoxide is actually a waste. So I don't need the mass of that. So percentage atom economy, percentage atom economy is equal to 112 divided by 140 multiplied by 100. That gives me 80%. Tungsten is a transition metal. Potassium is a group 1 metal. Give two differences between the properties of tungsten and the properties of potassium. Now, tungsten has a higher melting point or boiling point. So you can either write melting or boiling point, but you can't write it as two different points. Tungsten is denser than potassium. So I'm going to write than potassium. We are trying to work out the difference, so there's no point in saying tungsten is dense. It doesn't actually compare that to potassium. You could also say, there's a couple of other things that you can actually say. So let me write the others. We are talking about tungsten. So tungsten is harder, or you could say stronger. You could also say is less reactive. or can be used as a catalyst, right? Or you could say has ions with different charges, or you could also say forms colored compounds. Tungsten oxide reacts with hydrogen to give tungsten, W, and water. The equation for the reaction is tungsten oxide plus 3 hydrogen gives tungsten plus 3 molecules of water. The law of conservation of mass states the mass of the products equals the mass of the reactants during a chemical reaction. Show that the equation obeys laws of conservation of mass. So, let's start with reactants. Reactants should be equal to the products. We're talking about the mass. So what are the reactants? WO3. They've already given us, done half the calculation. So 232 plus molecule of hydrogen is 2 because there's 3 of them here. So that will be 6. So that is 238 grams. Products is 184 plus 3 molecules of water, 18 times 3, that's 60, 56 grams. So 56. Is it 56? No, it's not. 18, 54 grams. Right? So that, if you add that up, it should give you 238 grams. The reaction between tungsten has a high atom economy. Why is it important to use reactions with a high atom economy in industry? You could say for sustainable development, or you could say for economic reasons. You could also say to minimize the use of energy or to minimize the waste formed, or you could say minimize the use of limited resources. That brings us to the end of question number 3, and I will see you in question number 4.